Now time for the final practice problem, number 67. So given this circuit, I'm asked to calculate total current and total voltage. Now at first glance it doesn't seem like I can do much with this, but let's figure out what we do have. Now the only real information I have to solve for anything is this part of the parallel circuit right here. Now what I can do is I can solve for the potential difference across here, and that's going to be the total of the potential difference of this resistor and this one. So I have to do 0.1 times 20 plus 0.1 times 40. And what that gives me is a potential difference across those two of 6 volts. Now the reason I have to include both of them is because they're both in series and they're both in the same branch of parallel. So if that branch has a 6 volt potential difference, then so does this one across the 20. That's useful because if I know that the potential difference across that 120 ohm resistor is 6 volts, I can just set 6 equal to the current going through 20 times 20. So when I solve for that I, we'll say this is I1. That becomes 0.3 amps. Now I have I1, which is 0.3, and I have the other branch, which is 0.1, so my total current is just 0.1 plus 0.3, which gives me 0.4 amps, and I'll put that up here. So, total current. So if my total current is 0.4, let me find the potential difference across this 15 ohm resistor. And I'll do that by multiplying 0.4 times 15, and that gives me 6 volts. So I know that if the potential difference here is 6 and here is 6, then those two added together gives me a total potential of 12 volts. And so that is the potential that's supplied by my battery.